Hi, and welcome to episode 5. We're gonna fix Falldown today. Really frustrated that I wasn't able to get it working for the last episode. So, we're gonna fix it. First thing is, I think I'm just going to get rid of the matrices completely. So they're too slow. I'm gonna get rid of the matrices. So yeah. Instead, what we're gonna do is we're gonna have 4 sets of pairs of numbers. I think this is what I'm thinking right now. It's gonna be an alternating set of walls that are always just going to be set. We're just going to assume that you hit a wall unless you have a special x-coordinate that is a hole in the wall. So unless you have that special x-coordinate, we're not going to let you fall through the wall. So yeah, that's going to be that's going to be the deal. So we're going to start off, we're going to clear the screen, and then M is going to be our alternator, I suppose. So it's going to be, we're going to keep that because it's going to be 1 and -1, I guess. Or actually, what we could do is we could let there be different states. So I guess the bottom, once the bottom reaches the top, then there would be one more state in which, I guess, okay, what I'm thinking is, there's eight lines on the screen. So we could have a line on the bottom on row 8, then it could move up to row 7, 6, 5, 4, 3, 2, row 1. But every even row there's going to be a new row at the bottom. So on row 2, there's going to be a new row on the bottom. When it's on row 1, there's not going to be a new row on the bottom. So it needs to wrap back to being row 8 again after 1. So there is exactly 8 states that the floors can be in, and I want to make it so that we can cycle through the floors. Basically, we can define the floors if they're on an even number, then we'll just know that we're programmed to have the wall, on an even number. But if it's odd, it'll be a different position where we're blocked. Now, I need a counter to keep track of the 8 different states. So maybe M should actually be a counter for 8 possible different states. So let's see here. Let's forget this. Okay, we're not gonna do these loops. Yeah, let's yeah, you know what? Let me just go ahead and get rid of all this, because this is all, I'm gonna rewrite this. This is all matrix related code. This code up here, however, isn't necessarily. This is, I would say, so right about here, I believe. Okay, so we output ourselves, we output a space, we can move left and right. Is that all? Is that functioning right now? Yes. Okay, so right now we just have, we're back to our infinite loop. Okay. I want to, I'm going to output on the top of the screen. I'm going to output M. So M is going to alter between the 8 different states. So M is going to start off as 1. Or actually, we're gonna start off M as 1, but right when we get into the loop, we're gonna check. I think we're gonna check if M equals 1. Then we're gonna set 8 as the new M. Okay. Or actually if M equals 0. So what we're going to do is we're going to subtract 1 from M. So M minus 1 stores M. So basically M is going to cycle from 8 through 1 and just keep cycling. So when we run Falldown, it's going a little fast, but it should be the numbers 8 through 1. And we're going to slow that down. But now, if M equals an even number, we need to create a new list. So we're gonna have 4 sets, 4 pairs of numbers. So we're gonna, I guess instead of using matrices, we can still use another data structure. So we're gonna use lists. So we're gonna store ones into each list. That way, if we ever try to access these, the program won't crash. So basically, list 1 will just be the first random coordinate that we decide is going to have a hole in it, and then list 2 is going to be the other random hole. So there will be 4. It'll cycle through 4 floors: the first floor, second floor, third floor, and fourth floor. And then once it cycles through all of those, every 2 ticks, we'll be moving and we'll be adding a floor. And once the last floor gets to the top, it'll revert back to the first floor. So we're going to take M and divide it by 2. If M, let's see here, if M is even, so if M divided by 2, if we'll say the fractional part of it. If the fractional part of M divided by 2 is equal to 0, then that's when we have our new floor being built here. So M divided by 2, we're going to save that. And we're going to save that into, I guess, W. We'll just use W as a simpler way to access it. So that's going to be our index for which list we're on. So we're going to take a random integer from 1 to 16, and we're going to store that into list 1 W. Okay, and then we're going to do that same with list 2. So whatever W is, that's going to be the new floor that's being defined at the bottom. So we want to draw that one at the bottom and draw the other ones accordingly to where their corresponding I guess, positions are. So if the new one is at W, then we want to go, if it's M, so if the new one, so if M is, let's say M is like 6, okay, that means we're using the third element of the list, and that means we're on the 6th iteration from 1 to 8. So we want, let me think here for a second. This is hard to think about this and talk at the same time. We basically want to modulate it, which means we want to start off outputting the first, whatever is being outputted at the bottom, whatever M is, we want that at the bottom of the screen. So let's say M is like 8, then the coordinate that we're going to output that line at will be at 8. Okay, so 8 is gonna be 8, assuming that 8 is M, and then that is our X. Okay, so let's say it's 7 instead. So it counted down 1. Or let's say it's at 6. Okay, that line that's being developed at 6, that needs to go to 8. I'm trying to think here. What am I doing? Okay, I'm just using these numbers to show you I'm not programming anything there. No, we're talking about the X of a particular, I'm sorry, okay. I've been thinking about this, trying to figure out what I'm actually doing. So the X is going to be X, I'm going to label that X1, and this is going to be X2. Okay, so there's going to be 4 floors, so actually there's an X3 and there's an X4. Okay, so this is what I was looking for. Okay, so if M is 8, well, we can just say X1 is at 8 for its coordinates. But the next one that was designed after that one was X2, and that's going to be at, that's actually going to be at 2. And then X3 is going to be at 4, and X4 is going to be at 6. So X1, after 2 iterations, it's going to be at 6. X2 is going to be rewritten, and that's going to be at 8. And then this one's going to be at 2, and this one's going to be at 4. So basically, each one that we're outputting, we have to add 2 for each. We have to subtract from it, I believe. So X1 is basically, we'll just pretend it's kind of at 0, which is like equivalent to 8 when you're modulating in this case, because we're not including 0. 6, 8, 2, 4. Yeah, so you subtract 2 from the original 1. So those are going to be the defaults. So the default for X1, X2, X3, and X4 is these right here. but depending on what number m is at, we're going to subtract from it. So let's see here. This is really difficult for me to think with all my other homework and things going on. Yeah, so let's do a loop for, let's see here, what can we use? B, I guess. B is 1 to 4. And we're going to loop through each of the lists, or each of the positions on the list. So we're going to output, the x is going to be 1, okay, but the y is going to be the important thing here. We're going to output basically an entire row, so 16 O's. And then the x, or the y, I'm sorry, is going to depend on, well, let's clear the screen before this so that it's easier to debug. So that we're seeing what's actually going on. In list 1 and 2 B's, we're going to output spaces at whatever that coordinate is. And let's save that coordinate as like our, let's just call it R or something like that. Okay, so we're going to calculate, the thing we have to do is calculate R. R is going to be our Y, so that's what I was trying to figure out before. So we have to be able to loop through it, but R is going to be like for our drawing of the entire screen for each iteration. So so B times 2 but it's got to depend on M, that's the thing. It's got to depend on M. I guess M plus B times 2, and then we got to modulate that. So if R is greater than 8, R minus 8 stores R. So that way if it's like 9, it'll be 1 again, it'll wrap. I'm not sure if this will work. It's going a little fast. I can't really tell what's going on. But it wasn't erroring, so that's a good thing. Let me slow this down. For K is 1 to 100. Let's try that. Oh, it looks like the floors are going up. Okay, that's good. That's definitely a lot faster than last time. The floors are being drawn at the bottom and they're moving up towards the top. I don't like how they're disappearing though. I don't want to clear the screen. So let's undo that. Let's undo the clearing of the screen. Let's make it go a little slower, but let's draw. Let's draw beneath each one. So we're gonna output R plus 1. No, what we're gonna do, we already used R there, so what we're gonna do is we're gonna say if R plus 1. Oh, okay, that's got to be a space. Okay, so we're gonna say R plus 1 stores R. So we're gonna change R. If R is equal to 9, then we're gonna store 1 into R. So we're still gonna wrap it, but we're basically incrementing it forward. And we're gonna output R, comma, 1, comma, and then what we're gonna do is just spaces. Okay, so that'll erase the old whatever the old row was. Ah, there we go. Okay, so now we have floors moving up much faster than last time. It looks a little less confusing, I believe. I think it looks a little better than before. I mean, it's definitely faster than the last time we programmed. It's still a little confusing. Maybe it just needs to be slowed down a little bit more. Let's try 400. Let's double this, how slow it is. There we go. Okay, so right there we are falling down. We're not falling down fast enough compared to the floors moving, but that's okay because we already have a loop to slow it down. So it'll definitely be okay because we can just loop our control as many times as we need to slow down the rest of the game. So basically we can just we can do a loop around this. So for, I don't know which variable we can use. I guess B, because B is not being used within this section of code. So we can just do B as like 1 to 50. So we'll be able to move around a lot before the rest of it moves. Yep. In fact, that's too much. Let's try doing like 10. Let's see how that works. Yeah, 10 looks good. Okay, now for the tricky part. Now we have to detect if we're actually hitting something, and that's going to be very important. So if y is less than 8, y plus 1 stores y. We're going to add to this. So we're going to make this into a testing loop. So only if y is less than 8 can we actually see if we're allowed in this section to add 1 to y. But then to add 1 to y, we also need to check if we're within a space. We're within one of the allowed spaces. So depending on where the wall is, we actually will have to raise the coordinate of our y if we're trapped by the wall. So that's two things we have to add. We have to add the ability to fall down the holes and not the walls, but we also have to add the ability for the walls to push us up, and if they push us up to the ceiling, then we lose. So if y is less than 8, then we can check. We're going to use m to check. So if actually we're going to use the same thing we did before up here, except here instead of adding b, we're going to actually add our own coordinate. So if we add it to y, I think is what we have to do. So if m plus y and we're gonna use r again. So m plus y stores r. And then r divided by 2 is going to give us our index. I believe. Did I even use w up here? Yes, but I think I used it inside that loop. Yeah, so I can use w again down here. So if r divided by 2 is w, then we can check if y, or if our x equals either our list 1 w or our list 2 w, then we can add one to y. But there's also the case that we're in between, so we're not actually on a wall. So we have to see if the fractional part of r is actually an integer or is 0 or not. So if the fractional part of r equals 0, then we'll do then we'll check that, but else we will just add it without any extra checks. So let's see if this errors or not. Yeah, it errors, invalid dimensions. So we were accessing w. What's w? W is 4.5. That doesn't make sense because I thought I was adding it. Let's go check why I tried to add 4.5. Oh, I'm sorry, a fractional part of w equals 0. There we go. Oops. It's still invalid dimensions. I'm guessing it's 5. So w should be like 5 or something. Yeah, okay, so I'm trying to access too far down. So what I'm going to do instead is, if it's 5, it just won't check. So we're only going to go into that if the fractional part is 0 and W is less than or equal to 4. Okay. That's not good. What was W that entire time that it fell? Okay, let's check what W is right here. So W is 6. I don't get why it would be 6. I'm doing something completely wrong though, obviously. M plus Y stores R. So if M plus Y. M is going to be what state we're in. We don't want to add that to Y. Because the number we're trying to get, W, is which wall we're looking for. Okay, so yeah, I don't want to divide R by 2, I don't think. I want to divide M by 2. Because I want to know I do want okay, so assuming let's say we're at Y, we're at like Y equals 5. The Y beneath us is Y equals 6. Okay, so there will be a wall beneath us at some point in time, depending on whether M is odd or even. So depending on whether our Y associated with the M don't match, then we will go. I'm going to take a bathroom break really quick. Okay, I'm back. Basically what I'm trying to figure out right now is a type of function that's going to give me, that I'm going to give the input, which is my coordinates, and the state of the floors, which is M. So the input is Y and M, and the output is two things, or it could be considered one thing. The output is basically which index I'm accessing, and that index could be a 0.5, which means I just don't access an index if it is 0.5. So basically the output could be considered another number that's 1 through 8. And I believe I'm doing some sort of adding them together. So I just want to kind of write down what the function is what the function actually has to do. So the inputs are going to be y and m, and we're going to say the output's w, or we're going to say the outputs are, how about? And w is just basically going to be half of r. So for y is, let's say the y is at 7. If the m is at 8, then we remember that in the first position we stored the first position of the first row in W in that first session, so it'll be in the first index. So R is going to be twice M, which is 2. So somehow 7 and 8 have to give me 2. Now let's say we're still at y equals 7, but like some time went by, so M is actually at 6. We need to stop, we need to somehow stop at whatever the next one was. And I believe the next one, I believe if M was 6, then we have a new, then the way it cycled through, I think, I can't remember if it was cycling up or down. And that's what I have to find out, is W going to increase or decrease? But 7 plus 8, what is that? That's 15. 15 minus 8 is 7. So even if you modded it, we still have a number. Let's see here. If y is 7 and m is 6, that means everything moved up 1. Let's go down here. How did we do this? M divided by 2 stores W. So our W was calculated, M divided by 2. So I guess if we're at position 8 and we're being created, the W is actually 4 and the R is 8, because we're doing M divided by 2. And that's if y is 7. So if m is 6, we'll say y is 5, okay, and m is 8. So we're up more, but we're in the same position. What was created? M is decreasing. So what was created before m was 8? Well, that was m was 2. So it was W, which is 1. R had to be 4. Okay, so I can see that wraps. And if y was 7 but m was 6, that means we're in the same position, but m decreased, so it's forward in time, which means whatever one was next, whichever one came next, but 6 divided by 2 is 3, so our R would have to be 6. So it looks like our R if our y is 7, then our r is going to be the same as the m. But if our y is less, then we're going into the past m. So if y went down, then we're increasing our w, because it increased from 4 to 1 modulation wise. Yeah, I don't. So let's do 3 and 8. So assuming that nothing changes from the m, if we were up even higher, then it would be whatever was formed twice before it. So what came before m was, I'm not even sure, because either way you go, it's going to come out to be the same number, whether it's the past or the present, because it's 2 steps. But anyway, what we could do is we could add 1 to y, and then we could subtract that from 8, or from m. And if m is still less than, if m is less than 1, we'll try subtraction and then we'll try adding, because I'm kind of unclear in my head how this is actually functioning, and it's kind of frustrating. So yeah, we'll just try adding or subtracting the y, and then if r is less than 1, then we're gonna add 8 to it. Usually when I design these things, okay, now I gotta find out why I'm just going through all the walls. Oh, I see. I gotta do x equals there. Okay, so that was just a little syntax thing. Okay, so I'm stuck at the top, I'm hitting the walls. I never added 1 to y. Oops. Where is that? Oh, here we go. Oh, okay, so I went through that hole. Now, we're going to use the same function. Whatever works correctly here, we're going to have to copy it up there to move us up when r is getting when m is getting increased. So if m is getting increased, we also have to do that same check up here. So if we have to fix that one, then we'll have to fix this one too. So we're taking m and we're subtracting y plus 1 from it. And we're storing that. We got to use a variable. I guess we can use R if we're not using it up here. So yeah, let's use R. If R is less than 0 or less than 1, then let's see here. If R is less than 1, then we're going to subtract from Y. We won't check for the holes on this position because we'll still be able to get through the holes just by falling. So we'll add that in later, but let's just test it for now. Okay. Uh-oh. Okay, so I fell through that hole. I don't like how it erases. Okay, so what we can do is we can store it as, if there's a wall there, we can just store the new T. That will keep us from erasing the wall. So we can do T minus 1 stores T or something, just something simple like that. That way we're not erasing the wall. It seemed like that time we were. So maybe, I don't know. I'm not sure. Okay, I'm falling through the wrong holes here, so maybe we do have to add the Y. That might be what it is. So, yeah, let's go ahead and do that. So we're going to add Y plus 1 instead of subtract it. Oh, and that comes with a change. That means we also have to add 8 to R if R is greater than. Oops. No, that's the wrong. I'm sorry. If R is greater than 8, I'm sorry, I did this wrong. If R is less than 1, what? Okay, let me change this back. I'm going to subtract Y plus 1. If I'll do it this way. If the fractional part of R divided by 2 is equal to 0, then we're going to increase y by 1. And I have no idea why I was subtracting 1. I mean, I have to subtract 1 from y here. I have no idea why I was doing y right here. That's r. R plus 8 is stored into r if r is less than 1. Because we're subtracting y from m, so it could be negative. Yeah, and the reason why I got away with it is because I wasn't accessing the lists. So that was just a brain fart. Let's see here, if r is less than 1, we're going to subtract that from m again, just like we did before. And now let's try this. So this, so the y, why is the y 0? Did I subtract 1? Oh, I did. Okay, so let's put a note here. Let's say if 0, death. Okay. But if y equals 0, we're just going to put 1 store as y, just for debugging purposes. But anyway, that's how we're supposed to die eventually. Okay, I just fell through a hole that didn't exist, so so that tells me that I think I should be adding y to it instead of subtracting. But then again, it should be pushing me up. I think it is, but I shouldn't be able to fall down through the wall. Yeah, something's not making sense. What am I... If it moves up... If it moves up, then I should move up with the wall, not go through the wall. If m minus y plus 1 See, the thing is, if m changes, but if m and y are changing, for example, if it pushes the y up, okay, now you have, let's say you could fall. Okay, so you're at some y like equals 5 or something, and the floor is below you at m equals 6. Okay, if it pushes you up, then your y coordinate and the m are going to change for the next time we get to this calculation. So the difference between them being odd or even should still be the same because they both changed one step. That's what's really confusing me. Okay, so m is 4, 3, 2. Maybe the y isn't getting subtracted from for some reason. Let me test this actually. Okay, so high is not getting outputted to the screen, I don't believe. So I think that's why we're falling through it. It's because we're not actually, the fractional part of r divided by 2, for some reason that's not getting to be 0. What is r? Oops. Oops. Okay, I'm gonna display r right here. No, actually we need to stop the program after we display r. Okay, so I'm going to display r and then I'm going to stop the program. Six. That's not a, there's no fractional part. Okay, we're going to stop the program here. Really? So we were subtracting from y. But suddenly it's like it's okay for us to fall, I guess. This is frustrating because I don't know which of these is actually happening. Is it falling because of this first? Of this? Is that true? Or is this false, which is allowing it to do it? Or is it true? What is W? I'm not sure. 'Cause it goes a little too quickly. Okay, but either way, I'm noticing that we're falling once. So I'm gonna go up here and I'm just gonna do that. Okay, so I can see more slowly what's actually going on. Okay, I'm gonna do a loop. So I'm gonna do 4B is 1 to 500. So we're gonna see really slowly what's actually going on. So I'm at the top. Nope, 500 is too slow. Let's try 5,000. There we go. So I'm at the top. I got written over. Okay. That's a bad place to put the loop because I can't see my outputtedness. So let's do it after we get outputted, I guess. which I'm assuming would be right here. I believe. Okay, so we aren't falling. Okay. Interesting. We aren't being pushed up, it looks like. We're just going down. And let's take a break here. I'm just gonna think about this for a little bit. Okay, I'm back. One of the most difficult things for me to convince myself to do with this is to do all the figuring out of it and debugging on camera, which is kind of difficult. It's almost embarrassing because I'm having a difficult time figuring everything out, and part of me just wants to like write it all out on paper, or maybe go through the program on paper, which I might be able to do that on camera. I think I'm going to try one more idea though, because debugging and trying to figure out your program when it gets complicated is actually one of the most important skills. So if I can successfully do that, then there will be a couple of advantages to that. I'll be able to get some feedback for one, but maybe I'll also encourage, someone else who might be having trouble, to convince them that, they can actually do it. Because I know I've programmed this before, and I don't think I had as much trouble the first time. So it might have just been a coincidence of how I went about it, but definitely still going to try to do this without using any paper, without trying to simulate it through. And I'm going to try one debugging trick right here, and that's going to be it's going to be a display of a statement. And I'm not going to use display. I'm going to use output. So 8 comma 1, and it's just going to say the word 1. Okay, and then I'm going to have a little for loop here, and I'm going to use Z for this just to make sure I don't mess up with any other variables. And I'm going to do Z from 1 to 1,000. So I'm going to see when that one gets hit. Okay. And I'm also going to see output Z, or I'm sorry, this is going to be the for loop. Oops. Anyway, I'm going to output, just to see what exactly is going on, I'm going to output the word 2 here. And now when I run Falldown, it should show me at the bottom. Okay, so 1, 2, 2, 2, 2. Okay, so I can see why it's falling. It's falling because of that second case, which is actually the first case when you look at the code itself. The case, the top. So it's actually not hitting the wall. It's actually hitting this case. So I don't think I don't think it's because of the size of W. It might be because the fractional part is actually getting messed up for some reason. So it thinks it's a space, which should not be the case if the y coordinate is getting moved up. So it should not be in a space. So I believe that w is going to be less than or equal to 4. And I can prove that by outputting here. I can go to 5, and then I can just print w's value. So I'm going to go down here and 2.5, 1.5, 0.5, 3.5, and it looks like I was actually wrong. Okay, so I guess that, well, it does make sense with the other code, because the other code I was sure that y was getting subtracted, so that explains why that explains that the other code was working. So it's actually this code that's broken. So okay, so I was wrong about w being, or the fractional part. Oh no, I was correct about that. Okay, so w was less than or 4. So yeah, I was correct about that, but the fractional part is not equal to 0, which means, oh wait, okay, so the other code is broken, because it means that the code thinks that we're in a space area when we're actually in a wall area, which is not good. Let's see here. M minus y plus 1. The issue with this... Oh, I think I know why. Let me check. I believe it's because I've already altered the coordinates of the wall, maybe? No, that can't be it. The wall doesn't really have coordinates. But did I alter m? Is it because m is already changed up here? That might be why. Yeah, because actually the wall moved up either way. So let me go ahead and okay. Okay. So, okay, so actually this looks like it would work. Let me... Yeah, okay, so that's what the problem was, I guess. I was adding y to both of those when I thought they should have been the same, when actually they shouldn't, because I was altering m. That was exactly right when I was actually changing where the wall was, and I was actually placing the wall on top of myself and then checking the floor beneath me, when I actually should be checking the wall that I just moved. So that's what the issue was. And you can see how long it took me to program this as opposed to how long it took me to just figure out that one little mistake. That is a big, if you can avoid that in programming, that is a good skill. So you can see that sometimes I am very poor at making my code let me, I made a mistake here. And that was leaving in this delay. Way too long of a delay there. Okay, so I am good. I'm falling. I'm not falling there for some reason. I'm falling not there. Okay, so it appears as though I fell in the wrong holes. I believe it is because I need to actually be subtracting y as I originally thought. So, or I should be adding y. So if r is greater than 8, then we need to subtract 8 from r. Also, let's get rid of this this 2 output and the w. Okay, so if r is less than 8 or greater than 8, sorry. And that's also what I should be doing up here, which doesn't matter actually at the top yet, so we can change that later, but I'll have to keep a note of it. But for falling, oh, that's not good. Oh, that's not good. That's not good. What did I just fall through? And we're having problems with erasing the wrong erasing after we moved back up. And I believe that's because I didn't set the T this time. I think I accidentally forgot to put that back in. Yeah, so T minus 1 stores T, of course. There we go. Oh, and instead of subtracting 1 from T, we will set T. We will set T equal to Y. I believe that should fix the problem. That way, no matter, well, what was T? T was 0. Well, wasn't Y 0 then? Or was Y trying to fall? Oh, I'm sorry. I need to change this to here. So Y stores T needs to be after the 0 check. Okay. So we are not erasing the floor anymore, which is good. Good, I fell through that hole. I fell through that. I fell through that. I fell through that. Okay. Okay, so it looks like I am falling I don't understand. Yeah. Yeah, so I don't understand how the floor can push it up, hold it up, then every once in a while it falls back through. That doesn't seem to add up. I think the first time I programmed this, instead of cycling through, what I think I did was I think I had 8 lists, and I think I just shifted down the coordinates, so it was very simple. It wasn't an array with like a different starting and ending point. It was actually just an array with the same ending point, and I just shifted the array, which actually did not take long at all. And I probably could have done that here and gotten away with it just fine. But I wanted to do it the most efficient way, which was to try not to shift anything, which doesn't really matter when you only have 8 floors, come to think of it, because that's only 16 numbers to move. And since you're generating 2 of them, then it's really only 14 numbers to move for those iterations. And it's going too fast as it is anyway, so it wouldn't have mattered. So yeah. I'm going to change this to a while loop. Just to ensure that it is getting all the way into the range that it needs to. Because I don't really know the range and domain of those. But I don't know why. I mean, It's almost like the way I'm testing it is different from the way I'm drawing it. Because the way I'm drawing it, I think the way I'm drawing it, I'm getting the Y value with R, which I'm taking M and I'm adding it to B times 2. So that number is going from less to more. Wait, M minus Y. So is R, but didn't I add it down here? M plus Y plus 1. What? I'm supposed to be adding it. I don't know if that's going to change anything though. Well, it's falling through everything now. It's like only at certain values does that hole exist. So it's like switching. So it's like going the wrong way. Yeah. Okay, so what I'm trying to do here is so awkward for me. It's very strange. I'm taking okay, so for B is 1 to 4. this works correctly. That's the funny thing. M plus B times 2 stores R. So I'm outputting 4 different rows. B is either 2, 4, 6, or 8. Okay. And M is any number between 1 and 8. But only at 2, 4, 6, and 8 am I actually drawing these, and then I'm looping. So if R is greater than 8, then I subtract 1 from R. So if I'm at 8, 8, I'll be 16, and then I can subtract 1 from 8 from R, and I'll be back to 8 again. So when B is 4, that'll be at the bottom of the screen when M is 8. But when M is, let's say M is 7, and B is 4, then we're going to be at 7, and so we're going to output at 7. So B4 is going to follow basically wherever M is. But like B3 is going to be offset. Okay, so if our Y, let's say M, like the floor just moved to the bottom row, okay. If we have 8 and M, and our Y is let's say our Y is 8, then our R is going to be 8, which means that we'll have the same that part works. It's the fall down part that's not working correctly. If we're checking the part that's below us, that's the part that's not working correctly. So if Y is less than 8, and that gives us the option to fall down. But y plus 1, that's like beneath us. So if we're at y equals 7, you know, we're looking at the wall on the first floor at 8. So we're checking y as if our y was 8 if there's a wall there. And then we're adding m to it. And m hasn't changed since the wall was established. Oh, I think I know what the issue is. I think if the y changes, well, if the m is 7 and the y is 7, then those add to 14. So we're checking 6, which is the third index. Okay, so if we're at 7, we're at the second to last row. If m is 7, that means that there's a wall on top of us. Which means there's no wall we have to check for, we can just fall. So we should fall if m is 7 and y is 7. Alright, I'm gonna take a little break. Okay, I'm gonna try something. Just, we'll pretend it's for fun. This is just for testing something that I'm thinking, which should be trivial, but for some reason my mind likes to have brain farts, so and I don't really comprehend exactly what I'm doing, so yeah. So if we take A plus B, we store that into C. Okay, our C's are R. Okay. Let's output that, or let's do our little while loop. So while C is greater than 8, C minus 8 stores C. And we're going to output that A, B, C. So what I've designed here is a chart where I'm checking to see which numbers are odd and which numbers are even. Because moving either way on this graph, M changes or Y changes just by moving up or down, left or right. It represents either a change in M or a change in Y. But as you can see, the numbers do change from odd to even. So therefore, we have correctly detected whether there's a floor or there's not a floor below us. Because no matter which direction I go in, the M and the Y, once I add them up, and even if I subtract 8 from them, it's still going to tell me whether, the number's odd or even. But, wait a minute, I forgot one step. C divided by 2 stores C. Okay. Oh no, I'm sorry. Yeah, because the fractional part, if you divide something by 2, is that what I'm looking for? Because 7 divided by 2, because that's how you check. Yeah. Let me guess, it was X. I hit X too many times. Yeah. I don't get how it can fall on some, but then it doesn't fall on others. Like, just doesn't make sense. Anyway, let me add in a simple little addition for the X, so we don't go off the screen. We wrap the screen instead. If X equals 9, 1 stores X. If X equals 0, 8 stores X. Now we can wrap the screen. Oops. Not 9, 16, and 17. I am foolish. Here we go, 17, 16, and we can wrap the screen. It is working correctly on the output though, right? Or is it? Did that just change? Oh! I didn't realize the actually... Wow. So this might sound crazy, but I'm gonna look for a line of code that I wonder if... Oh no, okay, no, M should be correct. Yeah, if M is less than... If M equals 0, then 8 stores M. So M wraps. What I'm finding out is we did something desperately wrong here with even the outputting, because the outputting is actually not even working correctly. I saw those lines change and I can't believe I didn't notice that before. That's ridiculous. This isn't even correct, and I'm out of batteries, so that was complete failure. Maybe we can try again next time.